Hello guys, good day. Welcome to my channel. Today guys, we will continue our learning session in project construction and management. We are now on learning session 6, which is entitled the network diagram. So this is part 2 of our learning session 6. Okay, so last time we stopped on the computation of the earliest start and the latest start to finish. So connect now, guys. Our discussion will be on the solving the float or slack time. Okay, so let us go to our presentation. Okay, so as I mentioned last time, we stopped on the computation of the last start and the last finish. Okay, so this is our example and this is the tabulated computation. So this is the summary. Okay, so as a brief recap on our uh, discussion on the part 1, when you are solving the early start and early finish for this one. Okay, so you are moving forward. Okay, so from the start to the end of the project. Okay, so you are going forward for ES and EF. Okay, so remember that the EF is equal to ES or early start plus the time or the duration of the activity. Okay, so for the last start and last finish, so this one, so you are going backward. Okay, so from end to the start of your project. Okay, so this is the tabulated figures. Okay, so this is the last start and last finish. Okay, so now for the solving the float or slack time, okay, so the term slack is used by a PERT, which is equivalent to float of a CPM network system. Slack or float is the word for those activities which do not fall on the critical path. Okay, so remember that one, guys. Then the formula for float, we have two formulas. So we can use last start minus the early start. Or we can use the last finish minus the early finish. Okay, so this is the formula for float or slack. Okay, okay, so now guys, we will try um, one example. So as you can observe, this example is the previous example for the early start and early last finish of the one. So this is our last example. Okay. So for this example, so this is the diagram. So I color code the formula. So for forward, I am using blue. Okay, so this is the computation blue. Then for the last start, last finish, so backward. So for backward computation, I am using red. Okay, so this one is for identification purposes. Okay, so that it will be easily identified. Okay, so the applications or the example will be easily identified. Okay, so um, our first objective for this example is we have to determine the length of each path, then critical path, and the amount of float time in each path. Okay, so this is the diagram. So let's review or recap this diagram. See, this is the start. Okay, so this is node 1. So after node 1, we have two activity on arrow. So we have 1 to 2, so 10. So the duration or the time for this activity 1 to 10 is 10 days. Okay. Then for activity 2 to 3, so this activity on arrow, so the duration or time of this activity is 6 days. Okay. So after the node 2 or after activity 1 to 2, there are two activities, okay, follow after completion of this activity. So we have activity 2 to 4, which has a duration or time of 8 days. This one. Then 2 to 5, activity 2 to 5 has a duration of 13 days. Okay, so this is the time for the completion of this activity. Okay, so after activity 2 to 4, this one, activity 4 to 5 follows. Okay, so this one. So the duration or the time for this one is 4 days. Okay, this one. Then on the other side, okay, so as you can observe, in our last activity, there are one, two, three path. Okay, so going to this uh, last activity. So for on this side, for activity 1 to 3, this one, the duration of this activity is 6 days for the completion of this activity. Then after this one, 3 to 5, the duration is 12 days. Okay? Now, so we have three activities coming to activity 5 to 6. Okay? For, and end of the koan of your project. Okay, so first, let's solve the EF. Okay, so this one, EF, early finish for this project or for this activities. Okay, okay, so for the formula is early finish is equal to early start plus D. Okay, so the for this activity guys, the early start for this one is 0. Okay, 0. Then the duration or the time is 10. So we have 0 plus 10 is equal to 10. Then for this activity, the early start for this one will become 10. So this one, so meaning the early start of 2 to 4 is 10 days. So the early finish of this one is 10, early start 10 plus the duration of the activity, which is 8 days. Okay, so the total is 18 days for this one. Then after this one, this 18 will become the early start for activity 4 to 5. This one. So the early finish of this activity will become 18 plus 4, the duration equal to 22. Okay, so we will stop from here because there are three paths going to the end of the activity. Okay, next we have this path. Let's try this path. Okay, so for this path, since they are the same, so 0 for the early start, then 10 for the duration. Then after activity 1 to 2, okay, so 10 will be the early start for activity 2 to 5. So 10 plus 13, which is the duration. So it will became 23. So the early finish of this activity is 23 days. Okay, so coming from here to here, 23 days. Okay, so let's stop for this one. Let's go to the third path. Okay, so for activity 1 to 3, for activity 1 to 3, for this one, uh, the early start is 0 once again. Then the duration or time will be 6. Okay, so 0 plus 6 equal to 10. So meaning the early start for activity 3 to 5 will be 10 days. Sorry, so this is not 10. So sorry, we have an error here. So this is actually 6. Okay, so let's try to edit this one. Okay, this is 6. Okay, okay, so 0 plus 6, 6. This will become the early start for this activity. Then the early finish for this activity will be 6 plus 12. This is the duration. This is the early start. So the early finish now will be 18 days. Okay. Since on this activity we have three figures to choose, okay, because there are three paths. For this one, we will choose the highest days among the path. Okay, so the highest days for this one is 23. Okay, so we'll choose 23 since it is the highest days. So 23 will be the early start, then plus 2 the duration. So the early finish now will be 25 days. Okay, so I hope it is you follow my explanation on the early finish and early start computation. So you are moving forward for this one. Okay, now for the last finish, the computations actually will become opposite. Okay, so you will be moving backward. Okay, so for that one, okay, so I will explain that one. Then for this one, remember that the last start, the formula is LF. Sorry, so for the last finish, the formula is last start, last D. Okay, so this one. So last start plus D. So this will be the LF, the last finish. Okay. So for activity 5 to 6, this one, the LS, the last start, will be LF minus D. Okay, so our LF is 25. Last start is 25 minus last finish is 25 minus the duration of this activity. So it will become 25 minus 2 equal to 23. So this will be the last start for this activity. Okay, so 23 days. Okay, so after that one, we have three path, paths, sorry. So we will go to first one in the up. So 23, so this will become the the last finish for this activity. So 23 minus 4, the duration, it will become 19. Okay? So 19 now will be the last finish for this activity. So 19 minus 8, the duration, the answer will be 11, or the LS, or the last start, will be 11. Now the 11 for this activity will be the last finish for this one. Okay, but as you can see, we have two paths. Okay, so I will stop from here so that we can choose, and I will explain to why the second path will be chosen. Okay, for this one, so the last finish is 23 for this activity. So 23 minus 13. So this is the duration. So the answer will be 10. Okay, so we have two figures on this node. Then for remember that in solving the last start, so we will be using now the minimum figure among the two. Okay, so the lesser number. Okay, so the lesser figure. So among the two, the lesser is 10. So we'll use 10. Okay, so for this one, we have 10, the the last finish for this activity, then 10 minus 10 for the duration. Now, the answer or the last start is 0. Okay, so it's the same with this one. So for the third path, for this one, we have 23. This is the LF, the last finish for 5 to 6. Then now will he this figure now will become the LF for activity 3 to 5. So 23 minus 12. 12 is the duration once again. So the answer will be 11. So the LS for this one or the last start is 11 days. For activity 3 to 1, the last finish for this one will become 11, then minus 6, the duration, the last start for this path will be 5 days. Okay? So those are the computations on the AS and LS. So I hope you follow guys. And for the critical path, okay, so this one, we have three. We have three paths. Okay, so 1, 2, 4, 5, 6. This is path 1. Then path 1, 2, 5, 6. This one. Then 1, 3, 5, 6. Okay, so determine the length of each path. Okay, so for the length, so we have 10, 8, 4, and 2. So the total number of days for this one is 24. Okay, then for 1, 2, 5, 6, so just add the duration or the schedule activity or the number of days per activity. So we have 10 plus 13 plus 2. So we have 25. Okay. Then for activity 1, 3, 5, 6, we'll just add 6 plus 12 and 2. The duration or the answer is 20 days. So in three paths, we have 24, 25, 20. Remember that the critical path is the longest route among the paths of the project. Okay, so this one, 25 days. Okay. Then for the float or slack among the path, so per path, so the computation will be critical path. So our critical path is 25 minus the length in weeks of each path. Okay, so for this one, 25 minus 24, we have float or slack 1 day. Then for critical path, okay, so actually in path, so critical path is usually have 0 float or slack. Okay, so 25 minus 25 will be 0. Then for the third path, we have 25 critical path, number of days, then 20 for this path. So 25 minus 20, this one is 5 days. Okay. Okay, so 1. So actually, this is the 11 minus 10. So this is 1. So I forgot to write or encode. So 1 day, 0, 0, and 5. Okay, so those are the computations and the ways in solving this kind of problem. Okay, so next we have, okay, so we have to solve now for the value of float or slack in its activity. Okay, so because in our discussion, it says that the slack or float is the word used for those activities which do not fall on the critical path. Okay, so we will check if this is true by using this formula. Okay, so let's go to the, okay, so actually this one is the figure. I copied that one in our previous slide so that we can visually see the figure and the table. Okay, so that it will be easy to understand. Okay, so now let us see the activity 1 to 2. So this one, activity 1 to 2. Okay, so let's, the formula for float is we will use last start minus the early start. So for activity 1 to 2, for LS, so let's try to, what is the LF? So the last finish for activity 1 to 2 is 10 days. Okay, minus the duration, so 10 minus 10 is 0. Okay, then for activity 1 to 3, this one, we have the last start is 11. This one 11 minus 6. This is the duration. So the last start is 5. Okay, so this is 5 days. Okay, so for duration, sorry, for activity 2 to 4, 2 to 4, this one, the last start for 2 to 4 is 19. Then the duration is 8. Okay, so 19 minus 8, so the last start for 2 to 4 is 11. Okay, so this one. Then for 2 to 5, 2 to 5, the last finish is 23 minus 13, which is the duration of 2 to 5. So 23 minus 13, it will become 10. So this 10 is the LS for activity 2 to 5. Okay, so this one. Then for activity 3 to 5, 3 to 5, this one, 23 is the LF, 23 minus 12, the duration. So the LS for that one on the last start is 11. Okay. Then for activity 4 to 5, 4 to 5, the last start for 4 to 5 is 23 minus the duration, which is 4. So 23 minus 4, 19. Okay, LS now is 19. So for activity 5 to 6, 5 to 6, the last start for 5 to 6 is 25. Then the duration is 2. So 25 minus 2 equal LS for this one is 23. Okay, so these are the figure of LS 0, 5, 11, 10, 11, 19, 23 from 1 to 6. Okay. For ES, for 1 to 2, for this one, remember that the node 1, the early start is 0. Okay, so we'll put 0 from here. Okay, then for 1 to 3, 1 to 3, the early start is 6. Sorry, 6. 6 minus 6. 1 to 3 is 6 minus 6. So the answer is 0. Okay, so for 2 to 4, 2 to 4, the early start is 0 plus 10. So the answer is 10. Okay, then for activity 3 to 5, the early start is 0 plus 6. Actually, this is 6, not 10. Okay, so the answer is 6. Then for activity 4 to 5, okay, so for 4 to 5, the AS is 10 plus 8. Okay, so 10 plus 8, so it will become 18. So 10, early, this one, early finish, then the duration. Then for activity 5 to 6, we have 10, 10 plus 13, this one, 10 plus 13, it will become 20. Okay, so now we already find the ES and LS for the activities. Then the next thing to do is we'll just to subtract the values from LS per activity minus the ES. Okay, so 0 minus 0, so the float is 0 for activity 1 to 2. Then for activity 1 to 3, we have 5 minus 0. So for the float for activity 1 to 3 will be 5. Then for 2 dash 4, we have the LS is 11, so minus 10, ES 1. This is the float for 2 to 4. Then for 2 to 5, we have 10 LS, then 10 DES is 10. So the float is 0. So 3 to 5 is 11 minus 6. We have 5. Then for 4 to 5, the float is 1, 19 minus 18. So 1. Then for 5 to 6, we have 23 minus 23, 0. Okay, now, if you observe the activities that belongs to the critical path, which is, okay, so let's go back. So the critical path is 1, 2, 5, and 6. Okay, so 1, 2, 5, and 6, which has 25 days, okay, uh, of completion. Okay, so for this one, as you can observe, activity 1 to 2, 2 to 5, and 5 to 6 has zero float. Okay, this one, 0, 0, 0. The other activities have float or slack on it. Okay, we have 1 to 3. Activity 1 to 3, imagine you have a float of 5 days, then 2 to 4 is 1 day, 3 to 5 is 5 days, then 4 to 5 is 1 day. Okay, so for that one, so it's very clear that the critical path has zero float. Okay, so meaning we cannot avoid delays for that activities. Okay, so this one is lack or float is the word used for those activities which do not fall on the critical path. Okay, okay, so let's go back. Okay, so I discussed already all the discussions in learning session 6, and I hope guys you learn something from from the discussion. Okay, so this is very important in managing a project. Okay, so what's the reason why these computations or tool, actually this is a tool for monitoring, very important in the project management. Let us say activities. If you are a project manager or project engineer, why this diagram is very important in the project. Okay, so the answer for that one is simply because you will know what are the activities that needs to be uh, let us say focus. So you have to focus on that activity because those activity, if one of that activity, especially on the critical path activities, is if one of that one will be delayed, meaning the entire project will be delayed. Imagine one of the critical path is, or you will be constructing a column. So you cannot construct the beam without a column. So that's one example, guys. So you need to know the completion. Example, you need to know the completion and the construction of the column before you can proceed to the construction, to the following construction. Example, the beam, the slab, uh, other activities related after the column. Okay, so that's the important. Okay, so if your your project is not well managed by well experienced personnel or technical persons, especially engineer and managers, so you cannot achieve the the project completion date that project. Okay, so the reason why you are doing this one to avoid, especially if you have projects in the government, they are very strict in the completion of the project actually. So if you will be late, so you will be penalized by way of liquidated damages. Okay? So but there are some instances that delays uh will be caused by example weather. So that is why in every construction you need to monitor your weather so that you will be uh you will the reason of the delay will be determined. Okay, so then you will report that one to the concerned, yeah, agency or the owner of your project. Okay, so that's the main reason, and I hope you learn something from this one, the competition or the construction of the diagram and knowing the critical path. Okay, so I hope guys you learn something, and that's all, and see you in our next learning session. Thank you.